This is 4.2, Dividing Polynomials, Day 3. Today we're going to be talking about the factor theorem. The factor theorem states that if c is a 0, if and only if x minus c is a factor of the polynomial, p of x. This means that the remainder would have to be 0. So one way to check that is to use the factor theorem by plugging in the remainder theorem, and if we plug in p of 2, we would get 2 to the third plus 2 times 2 squared minus 3 times 2 minus 10. Now if this equals 0, then x minus 2 would be a factor. So here we get 8. 2 squared is 4, and 4 times 2 is 8. Minus 3 times 2 is 6, minus 10. So this is 16. 8 plus 8 is 16. 16 minus 6 is 10. And 10 minus 10 is 0. So that means our remainder, if we were to divide this, our remainder would be 0. So therefore, c minus 2 is a factor. Another way to use this information is to show that a given value of c, given a value of c that is a 0 of p of x, we can find all the other zeros. So if we take this and we do synthetic division, we put our 1/3 on the outside. We take 3, -7, -7, and 3. And we can do the synthetic division here. So we bring down the 3. 1/3 times 3 is 1. And again, we are adding with synthetic division. So -7 plus 1 is -6. -1/3 times -6 is going to give us -2. -7 plus -2 is -9. And 1/3 times -9 is -3. And 3 plus -3 is 0. So we have this 0, which means we have a factor. This quotient here, the remaining polynomial, is another factor. And what we want to do with that is write this out. Since we started out with our regular original polynomial as a x cubed, this is going to be x squared. So 3x squared minus 6x minus 9. And this is a quadratic that we can either factor or use quad 3 on our graphing calculator. If we factor this, we will get 3x plus 3 and x minus 3. If we set each factor equal to 0, we will find the remaining zeros. So 3x plus 3 equals 0. Subtract your 3. You get 3x equals -3. Divide by 3 and you get x equals -1. When we set x minus 3 equal to 0, we get x equals 3. So we have those two zeros are the remaining zeros. So for all of our zeros, we have 1/3, -1, and 3. Over here we have another example where we want to find a polynomial of the specified degree that has the given zeros. So we want to find a polynomial that is a degree of 4 and the zeros of -2, 0, 2, and 4. What we want to do is we want to convert the I want to convert these zeros into factors using x minus c. So x minus negative 2, x minus 0, x minus 2, and x minus 4. So when I rewrite these, clean this up a little bit, I get x plus 2, x, x minus 2, and x minus 4. Now, in all reality, I can just multiply from left to right, and I will end up with my polynomial. But what I see here is I've got x plus 2 and x minus 2. And if I multiply a minus b times a plus b, my final answer is a squared minus b squared. That's a special product. So I have x squared and 2 squared. So x squared minus 2 squared is x squared minus 4. So now I've multiplied those. Now I can multiply the x. I can distribute to the x and the 4, and I will get x squared minus 4x. Now I need to multiply these two. Well, x squared times x squared is x to the 4th. X squared times negative 4x is negative 4x to the 3rd. Negative 4x times x squared is negative 4x squared. And negative 4 times negative 4x is positive 16x. And none of these can be combined, and that is my polynomial that has a degree of 4 that would have these 4 zeros. And the last example here is to find a polynomial of the specified degree whose graph is shown. So I have this graph, and I want to create a polynomial that is a degree of 4. And what I want to notice is that I have a 0 here at negative 2. I have a 0 here at negative 1. And I have a 0 there at positive 1. I have a negative 2, a negative 1, and a 1. Now, because I have the graph, I want to use my understanding of the behavior at each of these zeros. Now, this graph goes straight down through negative 2. So that is a linear behavior. So my exponent on my factor for negative 2 is going to be 1. I am also going straight through the negative 1. So again, that is linear, meaning the exponent will be 1. Now, on the 1, I am coming down and back up. So that's like a parabola type of look at that 0. So my exponent on that factor will be a 2. So now to create these factors, I just need to put them into x minus c. So I have x minus a negative 2. I have x minus a negative 1. And then I have x minus positive 1. And that one will be squared. These other two have just an exponent of 1. So I get x plus 2 and x plus 1, and then x minus 1 squared. So this one, because I have x minus 1 squared, I'll go ahead and do x minus 1 times x minus 1. And when I do the FOIL process for this, I get x squared minus x minus another x, and then plus 1. So x squared minus 2x plus 1. When I multiply these two together, I get x squared plus x plus 2x plus 2. And I get x squared plus 3x plus 2. So now I need to multiply these two together. And this is going to use the same process. It's like FOIL, but I've got 3 terms and 3 terms, or you can do the box method. So x to the fourth, I'm going to give myself plenty of room here. X times negative 2x is negative 2x to the third. X squared times 1 is positive x squared. Now 3x times x squared is 3x cubed. 3x times negative 2x is negative 6x squared. Negative 3x times 1 is 3x. And the last one, 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 1 is positive 2. Now I just need to combine like terms. So I get x to the fourth. I'm done with that. I look for x cubes. So I have negative 2x cubed, positive 3x cubed. Put those together, I get positive x to the third. Now I have x squareds. I have x squared, negative 6x squared, plus 2x squared. So that's going to give me x squared, and 2x squared is 3x squared, plus a negative 6x squared, that's negative 3x squared. And then finally I have a 3x minus 4x, which would be minus x, and then the plus 2 at the end. And there is my polynomial with the three zeros with a degree of 4. And that concludes chapter 4.2. Thank you.